All right, have your textbooks out, open to page 186. While you're turning in your textbooks, we've been spending the last couple sections talking about the space contained inside a figure. What do we call the space inside a figure, Bryson? Luciana, help them. Area, Bryson. What do we call the space contained inside a figure?
Area.
What is area?
Area is the space between something.
Contained inside a figure. Now, mostly what we spent our time talking about at first were different types of polygons. And the smallest of all polygons, as far as the number of sides, is a triangle. How do we find the area of a triangle? What's that formula we would use? Corey?
A equals 1/2 BH.
Good. A equals a half BH. But our most basic of all polygons is a rectangle. And how would we find the area of a rectangle? Kirsten?
A equals LW.
Good. A equals LW. Now, by the length, you could refer to this length as a base if you wanted to. You could refer to this width as a height if you wanted to, I suppose. But we usually think of them as length and width. If I slant the rectangle, we now have a parallelogram. What's the formula for the area of a parallelogram, Sam?
Is it A equals BH?
Good. A equals BH, where H is not the slanty side, remember. The H is the perpendicular between the two parallel bases. What if we had a perfect square all the way around? What's our formula for the area of a square, Ben? Now you start to say P. Then we do have a formula for perimeter of a square. P equals 4S. What about the area of a square? Michael?
A equals S squared.
Good. A equals S squared, the square of the side. And then we had a really unusual one. We had one where we had two lines that were parallel and then two lines that were not parallel. And we call this class a trapezoid. Michael, what's that formula for the area of a trapezoid?
A equals 1/2 H times the quantity B1 plus B2.
There we go. Where we said the first thing we have to do is add the two bases together, the top base and bottom base. And then one of them we would take half of, kind of like we did with the triangle. But then yesterday we began looking at a non-polygon. And what is that figure, that common geometric figure that is not actually a polygon at all? Elaine? She gets all choked up thinking about it.
Yeah.
Oh, I've got her mind spinning in circles here. What is that non-polygon that is commonly used in geometry? It's a figure, but it's not a polygon. It's not got straight lines all the way around it. A circle, right? And for the circle, we said, pretend that's a circle. We said we're going to find the area of the circle with the formula.
It's like pi r squared.
Good. Area equals pi r squared. There we go. And I know what some of you are thinking just coming off the holidays, like, Mr. Dasky, pi are not squared. Pi are round. Cake are squared. Pi are not squared. But in the formula, pi r squared. Now, the problem is, what if we're given a diameter? Do we have an area formula that uses diameter, class? No, we don't. And so if we were given a diameter instead of a radius, remember diameter is that chord that goes through the center. If we were given a diameter, class, we just have to cut it in half before we square it, right? So you'd have to cut it in half to find the radius, then square what you've got. We only want to use a radius when we use this formula. So we've got, 6 different formulas, area formulas that you need to keep track of. Know what to use when. Now the good news is this. Let's suppose on a quiz or test, there were a question asks you to find an area, and you remember the formula, so you wrote that down, hint, you wrote that down, and then somewhere along the line you messed up the math. Well, I would give you partial credit just for knowing the right formula to use. So, hey, memorize the formulas and use them. You were using these formulas for numbers 19 through 23 on page 186 to 187. Let's take a look at those, and then we'll take a look at some circle-y stuff that you also had questions about. Make sure you use units in your answer, Ben. That continues to be a problem. It will continue to cost points when we get to quizzes and tests. So get in the habit of using units. By the way, what kind of units do we use for area, class?
Square.
Square units, yes. And so number 19, go ahead and read that for us if you would, Jalen. Number 19, you're on the right page, page 186. Read number 19 for us.
A climbing wall is the shape of a trapezoid. The height is 55 feet, and the bases are 150 feet and 75 feet. What is the area of the climbing wall?
All right, so which of the formulas did we want to use, Jalen?
A equals 1/2 h times the quantity b1 plus b2.
Excellent. A equals 1/2 h times the quantity b1 plus b2. And so the first thing you had to do was?
Add the two bases together.
Add the two bases together. And when you added the two bases, you got?
225.
225. Of course, the height, it told us, was? 55. And then we also had the half. Now, unfortunately, on number 19 class, none of these are easy to cut in half. So I said what you could do, if you don't want to cut any of them in half, you could just multiply these and get your answer, and then multiply your answer then, class, by 0.5, or divide by 2. Either way you wanted to work it. What did you get for your final answer on number 19, Jalen?
A equals 6,187.5 feet squared.
Good, 6,187.5 feet squared. How many had that answer on number 19? Didn't work out beautifully, but we got to stick with it. Questions on number 19. Does anyone need to see the multiplication shown out? Well, let's move on to number 20. Read that for us, Bryson.
This footprint of the office building was built in the shape of a trapezoid. The bases of the trapezoid are 93 feet and 84 feet. The height of the trapezoid is 36 feet. Find the area of the first floor.
All right. And so, once again, we need what formula here, Bryson?
A equals 1/2 h, multiplied by the quantity of bh plus b1 plus b2.
There we go. So the first thing you had to do was?
The basis.
Add the bases. And when you added the 93 and the 84, it gave you?
177.
177. Okay, that's not going to be easy to cut in half. Of course, the height it said was?
36.
Now that's not too bad. We can cut that in half because it's an even number. If you cut the 36 in half, it gave you 18. And when you multiply the 18 and 177, it gave you your final answer?
3,186 square feet.
Good. How many had 3,186 square feet of office space on the first floor? Good questions on number 20. Yes, sir.
Don't you just find it weird how it said find the area of the first floor?
Well, there's a couple reasons for it. Because if you said find the area of the building, well, what if it's a 5-story building? You see, it didn't tell us how many stories there were. And so also some buildings, not very many, actually have tapered walls. Kind of weird. Or they might have on another higher floor, they might have a patio area. So they just said for the first floor, just find that one. That way it's not like, well, we couldn't find the area of the building because it didn't tell us how many floors there were. So they were preempting smart alecky questions. But yes, I did notice that. I was like, interesting way to phrase it. And of course, I realized why they did that. But yeah, interesting. Number 21. Read that one for us, Luciana.
A rectangular city block has a length of 900 feet and a width of 600 feet. Find the area of the city block.
All right. And since it's a rectangle, we would use the formula.
A equals LW.
A equals LW. We just multiply the length and width. Now, really, truly, there's a shortcut we can use here, Luciana, because I don't want to multiply 900 times 600. I'd rather just multiply
9 times 6.
to get,
54.
how many zeros do I have to tack onto the backside, though?
4.
4 zeros that I hung to get.
540,000 feet square.
There we go, 540,000 square feet. By the way, you don't have to know this. I did when I was in 7th grade. They've taken this out of the textbook. We had to memorize that there are 43,560 square feet in an acre. Okay, we memorized that number, 43,560 square feet. I remember being in 7th grade learning that back when I was a boy. But anyway, so think about it. There's 540,000 square feet. That means that this city block is over 10 acres, right, of space. So it's pretty big. Number 22. Read that one for us, Michael.
A triangular window has a base of 50 centimeters and a height of 45 centimeters. Find the area of the window.
I am trying to picture triangular windows. You don't see those very often. You see circular or semicircular windows, right? I obviously square and rectangle windows, but a triangular window. I'm trying to picture where I would see one of those. I don't know. Maybe Maybe a building that has like an A-frame at the top or something might have a triangular window set in it, something like that. Maybe that's what it is. Anyway, there's a triangular window, 50 centimeter base, height of 45 centimeters. What formula do we use, Michael?
A equals 1/2 BH.
There we go. And which of the two, the B or the H, do we want to cut in half?
The E.
The base, because it's easy to cut in half. We just get,
25.
we multiply the 25 by the 45. We get what area for number 22?
1,125 centimeters squared.
Great job. How many had the answer on number 22? All right, no pressure, Kirsten, but we're perfect so far. Number 23, Kirsten, read this one for us.
A large advertisement is in the shape of a parallelogram. If the length of one side is 8 yards and the height of the advertisement is 6 yards, what is the area of the advertisement?
All right, and so it should more specifically say not the length of one side is 8 yards, but the base specifically is 8 yards. Well, what if it's the slanty side that's 8? I don't know then. I mean, I don't know. How do you find it? So anyway, let's assume it's the base that's 8. Since it's a parallelogram, what's our formula?
A equals BH.
And so we just multiply the B and the H and we get what?
48 yards squared.
48 yards squared is correct. We were perfect as we went around for these 5 students. How many of you individually were perfect? 5 for 5 on these. How many 4 out of 5? Just missed one of them. Are there any questions on any of these word problems? Start with the formula. Let it be easy. Let the formula tell you what to do. Let the formula tell you when to cut something in half. Let the formula tell you when to add a couple things together. Let the formula tell you when to multiply. That way you don't have to think that through. That's the purpose of those 6 formulas. Turn over now to page 188. And we began looking at the circle yesterday again. Class, what's the formula for the area of a circle?
A equals pi r squared.
Oh, I heard some mumble echoes there because you're like, wait, what? So let's try it again all together, class. A equals pi r squared. Again, formula for the area of a circle?
A equals pi r squared.
And it's important for you to be very comfortable going back and forth between a radius and a diameter. So on number 1, all you had to do is you turn the page just one page over, page 188. All you had to do was fill in the chart. They either gave you a diameter or a radius. You had to tell what the other one was. So for circle A, which by the way means that the center of the circle is point A, if there's an 18 centimeter diameter, then the radius is?
9 centimeters.
9 centimeters. Good. For circle B, a 12-inch radius means a diameter of what, Sam?
6 inches.
Oh, if the radius is 12, remember the radius is the little line. The diameter is the full one, right? So if the little line is 12, then the whole line must be 24 inches. Letter C, if we have a 30-yard diameter, Elaine, that means the radius would be? 15 yards. For circle D, we have a 45-kilometer diameter. It's a big circle. What's the radius of the circle? Just put your feet down, Corey.
22.5 kilometers.
There we go, or kilometers, emphasis on the second syllable. Letter E, we have an 11-kilometer radius. What's the diameter? Griffin?
22 kilometers.
22 kilometers. And circle F, as you set up, Jalen, if the diameter is 52 miles, really big circle, what is the radius? 26 miles is correct. Now again, for finding circumference, class, you can use the diameter. What's the circumference of a circle? C equals pi d. But for the area, you have to know the radius. Because the area is, class? A equals pi r squared. And what does r squared literally mean, Bryson? It means you multiply what?
You multiply the same thing. Or that you multiply it by the same number.
By the same number, by itself, right? So you would take the radius times itself. So as we look at number 2, it shows us that the radius of the circle is 3 inches. Well, before we can do anything else, we've got to multiply those 3 inches by itself, another 3 inches to get what for the r squared? 9 inches squared. Then we multiply the 9 by pi. Now, of course, pi, class, we generally use 3.14, unless we've got a really good reason to use what fraction? 22 sevenths. Is pi actually equal to either of those values? No, it's approximately equal to 9. Does that jive with the 22 sevenths, class? Now, we'll use the 3.14. What's the area on number 2, Bryson?
28.26 square inches.
Good, approximately 28.26 inches squared is correct. Number 3, they give us a diameter of 8 yards. Is that any good to me, though? Luciana? No. What do I got to do with the 8-yard diameter?
Split in half.
Cut it in half to get what for the radius?
4 yards.
4 yards. Then what do we do with the 4-yard radius, Ben?
Multiply it by 3.14
Well, not yet. Remember, pi r squared. So I got to multiply the 4-yard radius by 4 again to get
16.
And that's what we multiply by the pi. Again, we're going to use the 3.14. What did you get for your answer on number 3, Ben?
I didn't get it right because I did 3.14 times 4.
Oh, okay, so remember we got to square the 4. Let's see, what did you get, Corey?
50.24 yards squared.
Approximately 50.24 yards squared is correct. Number 4, they give us a radius of 7 centimeters. What do I need to do with that, Sam?
I need to multiply it by itself.
Multiply by itself to get 49 centimeters squared. Then multiply that by, oh, wait a second, 49. Class, what could I very easily multiply 49 by?
22.7.
If I multiply it by a 22/7, it cancels beautifully, class, to give me a,
7.
which I can then multiply to get approximately, anyone do it this way?
154.
154 centimeters squared. If you had this as your answer, I would take it and then probably put a smiley face because you did it the lazy way. However, it would not be wrong to also multiply the 49, Sam, by 3.14. Your answer won't be quite as pretty, but it'll still be a correct answer since it's an approximation anyway. I assume you did it that way? You did not do it that way. Who multiplied by the 3.14? Elaine, what'd you get?
153.86 centimeters squared.
Good, approximately 153.86 centimeters squared is correct. How many had that answer? How many, either one of the two answers, either that one or the one Elaine just said, you had it correct? All right, questions on using the formula pi r squared. All right, how many say, I may not have gotten them all right, but I feel like I understand it now? Okay, questions at all? If you're given the radius, what do you do with the class to find the area? Square. Multiply by itself and then multiply by, well, pi in general, okay? And then whichever form of pi you want. And then if you're given a diameter, class, what do you have to do?
Cut it in half.
Cut it in half and then multiply it by itself and then times pi. There we go. Circumference, different story. Area, pi r squared. Do 5 through 7 at your seats. Do 5, 6, and 7 now. You did 1, 2, 3, 4 for homework. Finish it out with 5, 6, and 7 at your seats. No cute pictures this time. We have to just kind of do the work, but. Please pay attention to whether they say D equals or R equals. Michael's finished. Griffin, Elaine. Ben, Bryson. Just a little longer to be finishing up. Corey. And Luciana. All right, for sake of time, pencils down. Let's take a look at these together. Number 5, a radius of, you got to be careful with your decimals here, 0.3 millimeters. What do you get when you square 0.3 millimeters? Griffin?
0.09.
Good, not 0.9, but 0.09 millimeters squared. So when you turn around and multiply it, 22/7 doesn't help me at all, by 3.14, how many decimal places are we looking at here, class?
4.
We're looking at potentially 4 decimal places. So we multiply the 0.09 and we get 0.2826. But notice the directions. We don't want this crazy answer. This is round answers to the nearest hundredth. After all, it's already an approximation anyway. So if we round it off to the nearest hundredth, how many decimal places is hundredth, class? 2 decimal places, right? Tenths, hundredths, thousandths, 10,000. We're going to cut it off here. Griffin, we're going to round it and say point. Bless you. Help him, Corey?
0.28.
0.28. The 2 is not big enough to bump the 8 up, so we'll just say 0.28 millimeters squared. How many had approximately 0.28 millimeters squared? How many had 0.2826? You just didn't round it off at the end. Okay, all right. How many forgot that when you multiply 0.3 by 0.3, it's 0.09, and you were missing a decimal place? You had 2.86. Okay, be careful. Remember, 0.3 times 0.3 have to have 2 decimal places in that answer. Look at number 6. We can't use that. 12 centimeter diameter? No. We have to change that. What do we need to make it say, Kirsten?
6.
6 centimeters for the
For the radius.
radius. There we go. 6 is easy to square. We just get.
36.
And then when you multiply it by the 3.14, you get what answer?
113.04 centimeters squared.
Good, approximately, but you did say 113. You didn't say and that time. Great job, I noticed. Approximately 113.04 centimeters squared. Great job on that. How many have that same answer for number 6? All right, make sure we cut it in half. Same thing happens on number 7. We can't use that number. We got to cut that in half, Jalen. Make it say 10 yards for the radius. When we square the 10, we get... and when you multiply by 100, class, what could you do with the decimal? Boink, boink. And so we get a nice, easy answer doing literally no work on paper. We're all doing it in our head. What do we get, Jalen?
314 yards squared.
Good, approximately. 314 yards squared is correct. How many got all 3 of them correct? All right, how many got at least 6 and 7 right? I know there's some decimal things on number 5. Who's got 6 and 7 right? Questions on 5 through 7. Let's drop down to the word problems now. Number 11, read that for us if you would, Ben.
The diameter of a quarter is 24.26 millimeters. Find the area of a quarter to the nearest whole number.
All right, so they're talking about like a quarter, like 25 cents, right? Which you have to pay to rent calculators or compasses and protractors and such, pencils, that kind of thing. And so to give us the diameter, they want to know the area at your seats. It does want you to round to the nearest whole number at the end, notice, because it's going to get pretty dicey with the decimals here. So at your seats, take a moment, find the area of a quarter. Very careful with your decimal places on this one. what's the first thing we gotta do with that diameter, class?
Divide it by 2.
Cut it in half, right? Divide it by 2. Make sure you get 12.13. How many got that first step? You got the 12.13? All right, now the fun begins. You gotta square it times pi. Problem, Corey? Square we gotta square the r first. Remember, we gotta square the radius before you multiply by the pi. Now, stop. Let's hold on real quick. Think for just a minute. Let's suppose you listen to everybody. You say, "Well, I remembered." It's okay. You might forget. Let's all think about a smart solution, because mathematicians are. We don't want to have to start the whole problem over again, right? Let's suppose you got the radius and you promptly multiplied by pi. You forgot to square, right? Well, think about what pi r squared means. Pi r squared means pi times r again, remember? Now, I think, I can't remember, my math classes run together because I teach so many, but I think we mentioned this before. You can add numbers in any order you want. Have we talked about that? How you can add out of order? I think we said that's called commutative. I don't remember if we taught that term this year or not, but we said you can add numbers out of order. 5 plus 3, 3 plus 5, big deal, right? You can also multiply out of order. 2 times 5, 5 times 2, no big deal, right? Well, if you multiplied r times pi, you've already done this much. Just multiply whatever your answer is by another r. So take whatever your answer is, just multiply by 12.13. Don't start the whole thing over again. Make sense? So ideally, you square the radius first, then times pi. But if you forget and you say, I got my radius, I multiply by pi, oh man, don't start over, just multiply what you got by one more radius, and you'll be okay. I gotta remember where I was. This thing's huge. I hope I'm right. Oh, good. That's a lot of work to be wrong. Say, Mr. Dasky, are we ever going to have one like this on a quiz or test? Not if you behave well. Tick me off. You never know what could happen on a math test. But you be good. And we might see about keeping these problems off your next math test. Yes, sir?
Is there any way, besides starting all over again, if you didn't know it was a diameter and
You accidentally just used the diameter? There technically is. Let me address that in just a moment. Yeah, I'll bring that up, because it is something we'll apply in higher levels of math. All right, so we don't spend the entire hour on one problem. Pencils down. Did anybody get 462.009866 like I did?
That was one off.
One off, all right.
I was 100 off.
100, I mean, that's a big problem.
I was too.
All right, so what we do, right, we multiply the 12.13 by 12.13, which is, 4 digits. So again, you multiply the 3, put a 0. Multiply the 1, put 2 zeros. Multiply the 2, put 3 zeros. Multiply the 1. And I point that out because some of us still having trouble remembering the zeros on speed drills and such. So just a reminder, you got to put those zeros in. The good news is they're all easy numbers to multiply. Like multiplying by 3, 1, 2, and 1, that's really easy. So even though it's big, it's fast. Now it's not quite so much, right? You got all kinds of different numbers. I like the 1 in the middle, I'm not going to lie. I love that about pi, is your saving grace is you multiply a 4, which isn't awful, but it's not fun. And you get a 1. It's like a little vacation in the middle, and you just write everything down that you already see. And then the 3, okay, you're back to some work again. Add it all up. We did have to round it off to the nearest whole number, which is just as well because, I mean, we get zeros for the next 2 digits anyway. It really is going to be really close to 462 millimeters squared anyway. Should have been our answer here. The question was asked a moment ago, Mr. Dasky, what if we don't notice it's a diameter? Is there a way to get around multiplying the whole blasted thing over again? Yes. Let's go back to this pi r squared. What is a radius, class?
Half a diameter.
It's a half a diameter, right? That's a good way to think of it. It's not the technical definition, but it's a great way to think of it practically. A radius, class, is half a diameter. So we could say this is pi times half diameter squared, right? Now, whenever we square something, that means times itself, correct? So this means pi times half a diameter times another half a diameter. Well, r times r is r squared. The d times the d is a d squared, correct? And you see the pi. And you say, Mr. Esky, you haven't done anything about the half and the half. You're right. What is a half times a half, class?
A whole.
No, that's a half plus a half. What about a half times a half?
1. 1/4.
1/4. 1 times 1 is 1, 2 times 2 is 4. So 1/4. So if you accidentally square a diameter, then times pi, and then go, oh shoot, I was supposed to do the radius. I don't want to start over. Divide your answer by 4 and you'll have it. For instance, do we have the answer to number 6 on our papers? 113.04 centimeters squared. Does everyone have that answer? All right. Let's just suppose we say, well, we know what 12 squared is, class. 144. And you're like, okay, I'm going to multiply that by 3.14. And you're just going along merrily. You get, that's easy. And you 12, 13, 4. Wait. Yeah, okay. And you get 6, 11, 12, 5, 452.16. Oh, man, that was a diameter. Divide it by 4. 4 goes into 4, class.
1.
4 goes into 5.
1.
With 1 left, 4 goes into 12.
3.
With nothing left, right? 4 goes into 1. 0. 4 goes into 16.
4.
Hey, that's the same answer. Right, so if, yes, to answer your question, then if you accidentally square the diameter, multiply by pi, and then realize your mistake, go through and divide it by a 4. Again, we'd rather not, because we don't like dividing. We don't like doing more work, but it's better than starting over, right? So, and dividing by 4 is not too hard. It's at least single-digit divisor. Good question. Let's move on to one that hopefully is not as painful. Number 12. Read that one for us, Sam. 11 was annoying. Number 12.
A circular disc with a radius of 5 inches is a cut from a sheet of metal. What is the area of the disc?
All right, so a radius of 5 inches. So it's about this big metal disc. Almost like a Frisbee size thing. I think a Frisbee is usually about 8 to 10 inches. So 5-inch radius would be about this. So we got a metal Frisbee, sheet metal, razor sharp. You chuck it through the air, ultimate Frisbee.
Yeah.
Don't catch it wrong, or you'll lose a finger. All right, anyway, so I digress. What's the area of the disc? Well, they gave us the radius. That was nice of them. It's not a crazy number. That was nice of them. So number 12 compared to 11 should be a piece of cake. Don't try to eat. Anyway, number 12, inch seats. Number 12. It's like, yeah, these kind of mistress. Give us these kind of quizzes and tests. These aren't bad. And most of you already have it. And what do we get for this one? Griffin.
78.5 inches or 78.5 inches, right?
Well, but area is always measured in what kind of units?
Square.
So inches squared. And we would also want to say approximately. Approximately 78.5 inches squared. Real quick, I didn't ask this class. We know the area of the circular disc is about 78.5 square inches. How big around will it be? At your seats. Find out how big around this disc will be. It's what, class? What's the term that means distance around? Circumference. At your seats, find its circumference. people are looking back. What is the formula for circumference again, class? What are our circumference formulas?
C equals pi d.
That's the main one. In this case, we want
C equals 2 pi r.
There we go. So if we double the radius, class,
10.
10. Oh. And 10 times pi,
31.4.
move the decimal back one spot. Note, remember, not square units on circumference, just on area. So it's 31.4 inches around. There's 78.5 square inches inside the circular disc. Questions on number 12?
No.
Number 13, and does anyone actually have a circular pool at home? I don't see circular pools. I guess a hot tub might be circular. You, all right, read number 13 for us, Ben.
The
Richardson's.
Richardson's circular pool has a diameter of 11 meters. The bottom of the pool needs to be repainted. What is the area of the bottom of the pool? Round to the nearest whole number.
That seems really big. 11 meter. Oh, diameter. Diameter of 11 meters. Okay, my brain was thinking radius. I'm like, that's enormous. 11 meters is still a good size. That's bigger than this room across. So in a circle, that's a good size pool. At your seats, find the area of the pool. Area of the bottom of the pool, technically. By the way, does anyone remember from your elementary days what we would talk about the total amount of water in the pool? That's not area. That would be called
Wait, no.
How much water is in the pool?
volume. Yeah, volume, right? So anyway, but we're not looking at how much water goes in the pool, just how much paint needs to cover the bottom, to coat the bottom of the pool. Seal cracks, that kind of thing. And is it nearest whole number? Yes. To the nearest whole number, class, we should have gotten approximately 95 meters squared. How many cut it in half? Got 5.5 meters for your radius. Multiply the 5.5, get 30.25 for the r squared. And then multiply that by the 3.14 and get that big ugly number. Not as ugly as number 11 though. But there's our answer, rounded to 95 square meters question, or meters squared questions on 13. All right, flip over to page 192. Flip over to page 192, and let's look at the review questions at the bottom of the page. They got a modified true-false section on here. Number 11, is it true or false? The sum of the angles in a triangle is 360 degrees. Is that true or false, Kirsten?
False.
False. What is the sum of the angles of a triangle?
180.
180. Where do they get 360 from? Class, what sum would be 360 degrees? Okay, Kirsten? What kind of angles in a circle? The central angles of a circle. In fact, I got ahead of myself. Number 12. The sum of the central angles in a circle is 360 degrees, class. That must be true. Kirsten just told us so. She wouldn't lie to us. Number 13. That's actually not the reason. Number 13. A right angle is formed by two parallel lines. Right angles are formed by parallel lines. Jalen, what do you think?
Perpendicular.
Perpendicular. Oh, I don't want to write the word perpendicular. We could use a symbol. Be lazy. What's the symbol, class?
T upside down.
Upside down
I
T?
just already spelled
We'll
it.
be lazy. Now, if you already spelled it out, I mean, more power to you. Number 14, an obtuse angle contains less than 90 degrees. Bryson?
That's false.
False. What should it be? An acute angle contains less than 90 degrees. Look across the page. They got some more modified true-false there. Number 11, true or false, a protractor is used to measure lengths. Luciana?
True.
Well, if it has a ruler across the bottom, yes, but the main function of a protractor isn't to measure lengths, but to measure angles. Very good, angles for number 11. Number 12, the diameter of a circle is twice the radius. Diameter is twice the radius. Sam, what do you think?
True.
That is true. If it had said the other way around, if it said the radius of a circle is twice the diameter, we would say false. The radius class is not twice the diameter. A radius would be half a diameter, if it had phrased it that way. But the way they phrased it is true. Number 13, the circumference of a circle is equal to pi r squared. Elaine?
It's area.
Area of a circle is pi r squared. Now, if it had underlined the pi r squared part, we would say, no, circumference is, it used to be up there, class, pi times
2 pi r.
2 pi r or
Pi d.
pi d. But it underlined the word circumference. We're going to change that to area. Number 14, the area of a trapezoid is A equals 1/2 BH. Griffin?
Triangle.
Triangle's a half BH, right? Trapezoid class is A equals 1/2 H times the quantity B1 plus B2. Number 15, a square is a parallelogram with right angles and all sides equal. Think for a second. A square is a parallelogram, picture that, with right angles. Now put right angles in your parallelogram and all sides equal. Is that true?
Yeah.
Yes, it is. True statement. What if they just said a square is a parallelogram with right angles? What do we call a parallelogram with right angles? That's a rectangle. What if it said a parallelogram with all sides equal?
Rhombus.
That's a rhombus. But with right angles and all sides equal, that has to be the square. Do numbers 4 through 7 on the same page. 193, numbers 4 through 7. Page 193, do numbers 4 through 7. Match your seats. Finished. Bryson finished. Tell you what, if you're finished early, see if you can figure out number 8. It's a weird one. It's not something we've talked about yet. But if you're done early, see if you can figure it out. There is a way to figure it out. Curious if you can do it. just a little longer on 4 through 7. We'll go over the answers, and then we'll talk about number 8. All right, for sake of time, pencils down. Let's take a look at our answers here. Number 4, what did you get for your answer, Elaine?
I did not get that one.
Ooh, number 4?
Mm-hmm.
The trapezoid?
I got the 8 and 12 is 20,
Uh-huh, and you cut that in half to get?
10,
And you multiplied that by 5 to get?
50.
That's the answer.
Oh.
50 inches squared. Yeah. Okay, 50 inches squared is correct. Number 5. Oh, that was a challenging one. They gave you the radius of 1.1, which is a little annoying. Jalen, what'd you get?
I got approximately 38 meters squared.
Ooh, little tiny thing. Kirsten,
Wait, what did she say?
she said 38 meters squared. It's not 38. Ben?
34.54?
No? Luciana?
Approximately 3.80 meters squared.
3.80 meters squared. When you square the 1.1, we know 11 times 11 is 121, but we need 2 decimal places. And we multiply that by the 3.14, it's going to give us 4 decimal places. So not 38, but 3.804 if you round. 3.804. Actually, wait. My book doesn't have the actual answer, so that's slightly annoying. So initial answer should have been 3.7994 rounded 3.80. Yes, meters squared. Number 6, back to Jalen for redemption. That parallelogram, what was the area?
8 equals 700 yards squared.
That was pretty straightforward, 700 yards squared. What about number 7? Finding the area of that figure there. Back to Ben.
56.
Ooh, 3 times 25? Oh, you found the perimeter again, Ben. Not 2L plus 2W. Length times width. Just multiply the 25 times 3. Think 3/4. How much money you got if you got 3/4?
75 cents.
75 cents. So 75 kilometers squared. Careful. Not perimeter. Area. Number 8. They give us this goofy looking shape. Like that. How are we supposed to find the area of that? Well, they drew a little line down here. Let me redraw it so it's a little more accurate. To show you that really what you see, class, is 2 shapes. What are the 2 shapes?
A
Triangle and a rectangle. Now this is 12 on this side, and it's 5 on this side. So if it's a 12 by 5, class, what's the area of the rectangle? 60. No big deal there. They also tell you that this little piece here is 7. If this piece is 7, class, how big is this piece?
14.
4, 7,
5.
This whole length is 12. This has come down 7 so far. How much is left? 5. And they also tell us that this piece here is 12. Well, if these are perpendicular, one of these could be the base and the other the altitude. But how do I find the area of a triangle? Not base times altitude, but half base altitude. Let's just look at this as the base and this is the altitude. Cut it in half. 6 times the base.
30.
If this is 30 in here, and this is 60 in here, what's the area of the whole thing?
90.
90 centimeters squared. Did anyone figure that out?
I was trying to look
I
at
got 490.
Does it make sense now how you would have done it? Homework for this evening. Homework for this evening. Page 189. You don't have to know how to do those. We're going to actually skip that section this year. But it's interesting. We will talk about it in 8th grade, though. So you will learn it in 8th grade. But for 7th grade, we're going to pass on that for sake of time. Page 189. Do numbers 1 through 6 in the homework section. 189, numbers 1 through 6. On page 199, do numbers 23 to 25. Page 199, do 23 to 25. Have a wonderful rest of your day, and you are dismissed.